Hello and welcome. In this video, we're going to be looking at some more examples of inverses. So last time we looked at um, finding inverses when we're given equations. So in this one, we're going to look at a little bit more of that, but the first thing I want to look at is inverses just from a set of points. So if we remember from last time, when we see the word inverse, we know we're supposed to switch the x and y. And if we have an equation, we would then kind of rearrange it to get the y by itself. But if we're given points, there's nothing really to solve. It's literally just switching the coordinates of x and y. So if the top 3 points are on my original function, then the inverse points are going to be those same values, but with the x's and y's switched. So this first point will become -2, 1. The second point will become 8, -6. And the last point will become 3, 4. And that's really all there is to it. Like we said last time, if we're given an equation, right, we would switch x and y first and then solve to get the y by itself. Once again, remember that the x and y are literally switching places, and everything else is going to be written in the exact same way before I start solving. So we would change y equals 1/4 x minus 8 to x equals 1/4 y minus 8. And then we would try to isolate the y or solve to get the y by itself. So of course we're going to want to add the 8 to both sides to give us x plus 8 over here and 1/4 y over here. And then we're going to want to divide by the 1/4 to get the y by itself. We also remember that the 1/4 needs to distribute to both the x and the 8. And lastly, if you are not good with the fractions and you're wondering how this is going to work, remember that you can use a calculator, and this basically works just like anything else. So if I want to know the number that will go in front of my x, right, I remember that if I don't see a coefficient, I treat it as a 1. So if I wanted to take 1 divided by 1/4, it would simplify to 4. And then for the 8, again, I'm just going to do 8 divided by 1/4, and it's going to equal to 32. So the simplified version of this inverse would be y equals 4x plus 32. In my next example, I'm given the equation y equals x squared minus 7. So once again, to find the inverse, we're going to start by just switching the positions of x and y and leaving all of the other numerical values in the same spot. So the exponent will stay in the same spot and the minus 7 will stay in the same spot. So wherever I see the y, I write an x. Wherever I see the x, I write a y. And then I just fill it in with everything else in the same position. And then once again from here, we solve to get the y by itself. So we're going to want to add the 7 on both sides. To get x plus 7 equals to y squared. Then we know when we see an exponent of 2, we can use a square root to cancel it out. And since the x plus 7 is all under the square root, there's nothing really to simplify there. We just need to remember to include the plus and minus sign because we recall from videos past that when you square something, a negative number would switch to a positive number. So we weren't really sure whether the y started as a positive or negative. Again, don't stress too much about that fact. Just remember that you put plus minus whenever you square root a variable that was squared. So the inverse of the original equation in this instance is y equals positive or negative square root x plus 7. And so for our last example in this video, let's look at one where we've got x being squared, but within the parentheses instead of the x squared with an extra number being added or subtracted at the end. So the general rule is still going to be the same. We're going to start things off by switching the positions of x and y. So I should see an x here, a y here, and everything else will stay the same. There we go. And then we're going to solve to get the y by itself. Just notice that the steps are going to be in a slightly different order this time because we can't mess with the 9 in the parentheses until we get rid of the exponent, right? So in the last example, the plus 9 was on the end, or rather, I should say the extra number was on the end, so we could get rid of it first. Here, it's grouped with the y, so we're going to have to deal with it last. So like we said, in order to get rid of an exponent of 2, we're going to use a square root. The square root is going to cancel the exponent of 2, so that side of the equation just becomes y plus 9. And then over here, since we square rooted the x, we'll just go ahead and put the plus minus right there. And so the last thing we need to do to get the y by itself is simply subtract the 9 from both sides. So the y will now be by itself because we got rid of that 9. On the other side of the equation, the square root x and the negative 9 do not combine together. So I could write it like this, where it just says square root of x minus 9. But if I do that, it's possible that if I write it too quickly, the line on top of the square root, you might accidentally write it a bit too long and then get confused because now you're thinking the 9 is inside the square root, which it should not be. So generally in situations like this, where only the x is being square rooted, we're going to want to put the x last just to, again, avoid that confusion. So we're going to want to say that it's negative 9 plus or minus square root x. There we go. All right, guys, that's all I have for this one. I will see you next time.